Welcome back, folks, to an exciting Chem 2 ACP video. Today we are going to be focusing on the last part of our mathematics and chemistry unit. Very exciting stuff. We're going to talk about units, dimensional analysis, and density. So really excited. Let's get going. By the end of this particular video, you will be able to understand and explain the variety of units that are found in chemistry. You should be able to convert between a variety of different units, as well as explain and use the density formula. We got a couple vocab terms for this, including SI units, mass, weight, derived unit, volume, density, and intensive and extensive properties. So when we talk about chemistry, we always want to put things in units. When we talk about measurements, measurements are always put in units. You don't just say, oh, this thing is 3 from the wall. Is it 3 feet? Is it 3 yards? Is it 3 miles? Is it 3 furlongs? There's a variety of different units that are found, but what we've done as scientists, I act like I had a part in it, what we've done is we've created a standardized system of units. That way, everyone across the world utilizes the exact same system of measurements. So you look at length. The unit is a meter. Mass, kilogram, times seconds. The amount is a mole, which you might be familiar with. Temperature, interestingly enough, is in Kelvin, not Celsius. So something to keep in mind there. Now, when we talk about mass, keep in mind that mass is a measurement of the quantity of matter. As we have more atoms, we have more mass. That's not to be confused with weight, which is the strength of gravity on mass. So when you put yourself on a scale, it puts it into pounds. That has to do with gravity's effect on the mass of your body. Remember, the mass of something is just how much matter it has. Weight is a little bit different, as it is the strength of gravity on that mass. So not everything can be described in just a single unit. Many times we have to use what are called derived units, which are units that come from combinations of SI units. So when we talk about distance, we talk about meters. Well, area is a square meter. It is a meter by meter. Volume is meters cubed, so it's 3 dimensions, right? You have an x-axis, a y-axis, and a z-axis. So a cubic meter is a sample of volume. You've got a bunch of other ones as well, including velocity, acceleration, force, torque, work, energy, power. Most units are derived units. That is, they come from more than one combination of SI units. Now, in order to represent numbers that are either really, really big or really small, many times we use Greek prefixes. These prefixes are used to quantify these large or small numbers. Now, the ones that I need to make sure that you know, and the ones that you will not be given, are kilo, milli, and centi. So, for example, there are 1,000 millimeters in 1 meter. The root milli means 1,000. So 1,000 millimeters in 1 meter. 1,000 milligrams in 1 gram. 1,000 milliseconds in 1 second. Centi, like the word cent, means 100. So there are 100 centimeters in 1 meter. There are 100 centigrams in 1 gram. There are 100 centiseconds in 1 second. The other root that you need to make sure that you know is kilo. Now, kilo is a little bit different than milli and centi. Kilo, there is 1,000 base unit in 1 kilo something. So, for example, a kilometer, 1 kilometer is 1,000 meters. 1 kiloliter is 1,000 liters. And 1 kilogram is 1,000 grams. Now, that's different than milli and centi. Okay, so make sure that you keep that in mind. Centi and milli, there are 100 of the centi or milli in 1 of the base unit. Kilo, it's the opposite. Keep in mind that temperature is a measure of kinetic energy. It is not a measure of heat. We've talked a little bit about this in previous science classes before. There are 3 primary scales that you're going to be taking a look at. One we won't use quite often is Fahrenheit. Unfortunately, it's the one we're also most familiar with. We'll take a look at Celsius as well as Kelvin. If you take a look on the right-hand side of your screen here, you see all of the different boiling points, freezing points, and absolute zero points of this particular scale. Now, Kelvin is what is known as an absolute scale, meaning that there are no negative values that are associated with it. So when you're at 0 Kelvin, that is what's known as absolute zero. That is the lowest amount of energy that atoms can possibly have. So make sure that you take a look and make those comparisons between Fahrenheit, Celsius, and Kelvin. Those will come up very frequently in this class. Now, there are a variety of different conversions we can make in between temperatures. We've got one that allows us to convert Celsius from Fahrenheit, one that converts Fahrenheit from Celsius, and one that converts Kelvin from Celsius. So if I give you a temperature, you should be able to convert to whatever formula you need. So for example, let's do human body temperature. Human body temperature is 98.6 degrees Fahrenheit. Let's convert that to Celsius. So all we do is we just plug in our formula and solve. So 98.6 minus 32. And we're going to multiply that by 5 over 9. And as a result, we will get our temperature. So 98.6 minus 32 times 5 divided by 9. So in Celsius, human body temperature is 37 degrees. But what is that in Kelvin? Let's say we have a Kelvin thermometer and we're measuring our body temperature in Kelvin. Wouldn't that be weird to measure temperature in Kelvin? I just like saying the word Kelvin. Let's plug that in and solve. Notice no degree sign with Kelvin. Okay, temperature conversions are very simple and very easy to do. Just make sure you follow your formulas. Now, as we have been talking about matter lately, we do need to understand the difference between intensive and extensive properties. Intensive properties are chemical properties that do not depend on the amount of matter. So, for example, density. It doesn't matter if you have one drop of water or an ocean full of water, the density of that water is still the same. It does not change just because you increase the amount of matter. Same thing with boiling point and freezing point. You have more water or less water, it still boils and freezes at the exact same temperature. Extensive properties do depend on the amount of matter, things like mass, volume. As the amount of matter increases, so does the amount of mass, and in many instances, the amount of volume. So remember that intensive properties do not depend on the amount of matter. I always think intensive inside. You can't change your insides. Extensive properties change based on the amount of matter. Extents, X like out. It does depend on the amount of matter. You see those changes. Now that we've been talking about intensive properties, let's focus on density. Density is the ratio of mass to volume. Another way to describe it is how compact matter is. And it is given by the formula D equals m over V, where D is density, m is mass, and V is volume. Now you know that mass is typically measured in grams or kilograms, volume in centimeters cubed or milliliters, so density, the unit for that, is going to be grams per centimeter cubed, grams per milliliter. It just depends on the situation. Typically, we see milliliters as volume for liquids, and we see centimeters cubed as volume for solids. But do keep in mind that 1 centimeter cubed is the same as a milliliter. Let's do a practice problem. Determine the mass of a cube that has a density of 11.4 grams per centimeter cubed and a volume of 8.00 centimeters cubed. Well, we know our formula, D equals m over V. Our density is 11.4. Our volume is 8.00, and our mass is unknown, so let's call that x. Simply do your algebra and solve. Now, our number should have 3 significant figures, right? It is based off of the number that's at least in our problem, and since we're we're multiplying, we're going to need 3 significant figures, because each of these has 3 sig figs. So that is going to be 91.2, and then since we are looking at mass, your unit is grams. Okay? Sweet. One of the biggest things that I'm going to focus on this year, and with any chemistry class, is dimensional analysis, and that is the process of how we convert between units. Many of you guys have done this before in math class, or if you've had a previous chemistry class. A conversion factor is a fraction that contains 2 different units but contain the same amount of something. So for example, a conversion factor between minutes and hours are that there are 60 minutes inside of 1 hour. They have the same length of time, they're just in different units. We work through one or multiple conversion factors to transform our starting material into what we are looking for. So if we can't get there in one step, we may have to do multiple steps in order to achieve what we are looking for. The units must cancel out through the process, leaving behind the unit we want for our final answer. And you'll see how that process works in just a moment. Again, this concept is very, very, very important, as we will be utilizing this in a variety of different math problems that you'll find in this chemistry class. Lastly, when we're talking about significant figures, very easy. Look at the number of significant figures in your starting material, and that will be the same as what your answer is. So keep those rules in mind as we dive into some dimensional analysis problems. The first problem here says to convert 550 centimeters to millimeters. Well, we always start with what's given to us in the problem. So let's start with 550 centimeters. Whatever unit is on top of the first step typically goes in the bottom of the next step. That is so that the units will cancel. Anything that's on the numerator will cancel with what's on the denominator. Now, we may not know a direct conversion between centimeters and millimeters, but we do know one with meters. Remember what I told you? Centi, 100 centimeters for every 1 meter. Now, we're not at our answer yet, so we need to do another conversion. We have a meter down at the bottom and millimeter on top of the last step. Remembering that there are 1,000 millimeters in 1 meter. Let's double check our work. If we double check our work, we should have the unit that we're looking for left over to be able to finish the problem. Centimeters cancels, as does meters, leaving behind nothing but millimeters as our unit. Now all we do is we plug into our calculator and solve. And what we get is 5,500 millimeters. That's how many millimeters are in 550 centimeters. We should have 3 significant figures in our answer. The problem is it's impossible to get this number to 3 significant figures. So we'll write it in scientific notation. So that way we can get it into the proper number of significant figures. So 5.50 times 10 to the third millimeters. The second one says, how many seconds are there in 1 year? We're going to start with a year. The question's asking for seconds. So we'll start with 1 year. Now, a couple ways we can go through and do this. I'd recommend going to days. Should have said non-leap year. Whoops. Day to hour. Hour to minute. Again, if there are conversion factors I don't give you, or there are conversion factors you don't know, I will probably give them to you. And now we do our math. So what we get, we won't use significant figures here because it's a little bit tricky. 31,536,000 seconds. You got that many seconds, better make them count. Let's get back to chemistry. So I have a driveway that is 10 feet by 60 feet. The price of the driveway is quoted in $220 per square meter. What is the final cost of the driveway? So here we're given, it's a little bit different here. That's our starting. We have a conversion factor between meters squared and dollar amount, and it wants to know the final cost of the driveway. Well, if I do some math here, 10 foot by 60 foot is going to give us a 600 square foot driveway. Okay, so I'm going to write that out as our starting amount. Okay. And so this is where it gets a little tricky because we're looking at a derived unit as opposed to a regular unit. So we're going to have to do a little bit of extra work. The key thing to keep in mind here, though, is that all of our units need to cancel. Okay? So what we need at the end is meters squared so that we can convert that to $220. Well, I don't know how many square feet there are in a meter squared, but I do know, and again, you'll be given some of this information, that 1 meter is 3.28 feet. Okay. Now this is going to be a weird instance, but we need to get rid of that feet squared in the numerator for both. So we're going to actually do the same operation twice. This is one of those instances where whatever unit's on top of the first step doesn't necessarily go on the bottom of the next step. So we take a look at that. We have feet squared up at the top, a foot and a foot down at the bottom. Those units now are canceling, and we're left with meters squared at the top. Now what we can do is we can put meters squared on the bottom and say, hey, that's going to cost me $220. Because again, 2 meters on top cancels the meters squared on the bottom. So now we can plug in and solve for our equation. So now the cost of our driveway is $11,220. Keeping in mind, use 3 significant figures. Okay? So again, take your time, work your way through it step by step, and you'll be able to come to the answer of the problem pretty much every single time. But like I said, this one's tricky because you've got derived units as opposed to regular units. Well, folks, that's the end of this video. Hopefully we were able to meet our learning objectives, that you understand the different units that are used in chemistry. You can convert between a variety of different units and then also explain and use the density formula. The key things here are that density formula and that dimensional analysis. That's going to appear on nearly everything that we do through the rest of the year. So it's really important that you understand how to do all proper conversions. We'll practice with some of this in class. This has been JLand Bio. Have a great day, guys, and we'll talk to you later. Bye-bye.